the last question in review set 8A, question 13. It's down here. Random variable t represents lifetime in years of a component of a solar cell. So part of a solar cell. The probability density function of t is given. Right. So for this to be valid, the integral needs to equal 1, which it does. I did do a quick sketch of this. So here's our little, starting from 0, because we're looking at time as our x value. So I've put in x there, but really it's time. Right. This would be f of t. And you can see the integral now. I just worked it out up to 100, up to 1,000. I don't know if it'll start stressing out Desmos. Yeah, that's. But you know, you can put in some high value there. The idea is that the area under the curve will sum up to 1. So it is a valid probability density function. Anyway, let's go back to the question. And perhaps you could ponder why that's 0.4 and that's minus 0.4 and that the integral equals 1. But the question doesn't ask us to do that. It just says find the probability that a particular component of this cell fails within 1 year. Right, so we've got this equation where f of t is the lifetime. Okay, so if we're looking on our graph, the solar cell can have some lifetime from 0 up to 1, which is what we're going to work out, be 0.329, 330. Right? It's obviously, like, this is obviously not a normal distribution, right? So you're going to have to do the integral. You're looking at lifetimes up to 1 year here, and you'd want the probability, so you want the area under that curve there. Right? Could last longer, could last 2 years, 3 years. So the quickest way to do this is probably just the calculator. I've shown it in Desmos, and I'm sure you can enter something like this into your calculator. 0 to 1, it was 0.4, e power of minus 0.4 times x dx, and we get out 0.33. Yep, my calculator gives the same value as Desmos, so that would be our working out. Where's the question again? Find the probability that fails within 1 year. So I'd be writing for part A here, the integral of the function that they've given me, probability density function times e to the minus 0.4. You know, it's f of t dt, and we got about 33%. Each solar cell has 5 of these components. The cell will work provided at least 3 continue to work. Right, we've just figured out how many fail. I'm going to define it that way. I could say let y be number of components that fail. they're starting to talk about 5 different components, and they've asked a question about if they fail or if they don't fail. Right. These are my clues that this is binomial, because fail or not fail is a binomial situation, right? And the fact that there's 5 is also binomial as opposed to just a Bernoulli. Probability it fails was 0.33. So that's a probability that 1 fails. Right? But now we're looking at a, if I select 5, or maybe none of them fail. I just lost my pen for a minute. Or maybe 1 of the 5 fail, or maybe 2 fail, 30%. So what's going to be the highest column? Probably the 2. 3, the chances that all 5 fail is pretty small. Right. We need at least 3 to work, is that right? I'm going to double check that. So if I carefully read the question, the cell will work provided at least 3 of the components continue to work. So that means we're okay if 0 fail, 1 fail, or 2 fail. So we need to cut off, if we're doing a binomial CDF in this, we need to say, what's the chance that 0, 1, or 2 fail? And we're looking at the accumulation of that. So we'll be doing binom CDF. Because that's the same as what's the chance that 3, 4, 5 succeed. Okay, so let's go to the calculator and have a look. Binom CDF, it's got to go down a bit for this. Make sure it's CDF. Got 5 trials. 0.33% of failure, but I only want to work out up to 2 inclusive. And we get 79.5% chance. Find the probability, and they want it as a probability, not a percentage. There was another question I did where I forgot to write the answer as a percentage, and I just left it as a probability. So you can put in, need my pen. You can use this as your working. What I've missed here though is some communication. Right. This is what I'm working out. The probability that the number that fail is smaller than or equal to 2. So whether or not you write this bit out here, it's up to you. It's not required, but it's not going to hurt you if you do. And now I forgot the answer. I think it was 79.5, 0.795. Okay. So that's it. 0.795, 3 sig figs, and that one is done. So there's an 80% chance roughly that the solar cell will still be working after 1 year, which is pretty rubbishy really, isn't it? Okay.